Hello everyone, welcome back to another video. Today in this video lesson, we're going to learn about acid and base, and in this video we will go through some stuff like the properties of acid and base, what counts as an acid and what counts as a base, um, some ways you can identify base and acid, and also the reactions that involve acid and base. So let's start. First of all, let's learn about the properties of acid and base. Moving this here. Okay, so here acid has a pH level of less than 7. It tastes sour. It can corrode metal. It frequently burns your nose when you smell it. It turns litmus paper into the color red, and it usually feels sticky. While base has a pH level of over 7, usually tastes bitter, does not corrode metal, it does not burn does not burn nose except for NH3, and then turns litmus paper into color blue, and also it feels slippery. So, what are acids and base according to some scientists? First, let's see the acids and base according to Svante Arrhenius. So, these types of acid and base we usually call as Arrhenius acids and base. And acid, according to him, acid is a substance that produces hydrogen ion when dissolved in water. So, for example, we have HCl or hydrochloric acid. If we dissolve it in water, it becomes chloride ion and hydronium ion. So this one can actually be further split into H2O plus H plus. So this is where the hydrogen ion come from. So that means hydrochloric acid, well, it's already in the name, but it's according to Svante Arrhenius, is a type of acid, while base is a substance that produces hydroxide ion when dissolved in water. So here we have sodium hydroxide. When it dissolves in water, it will become sodium ion and also hydroxide ion. So according to Svante Arrhenius, sodium hydroxide is considered a base. Next, we have acids and base according to Johannes Bronsted and Thomas Lowry. So this type of acid and base, we call them as Bronsted-Lowry acid and Bronsted-Lowry base. So let's see what acid is. Acid is, according to them, a substance that donates protons. But of course, we cannot just donate proton in the form like proton. So we, in other words, we can say acid is a substance that donate hydrogen ion, because usually hydrogen have one proton and one electron. But here you see H plus. That means its charge, it loses one electron. So what is left now is only one proton. That's why it can be considered as donating protons. And meanwhile, base is a substance that accept protons. So let's see in this equation, hydrochloric acid plus H2O or water will become chloride ion and also hydronium ion. Here we see HCl turn into Cl, which means HCl donates its hydrogen ion. That means that HCl here is considered as Bronsted-Lowry acid, while water here receives an hydrogen ion, become hydronium ion. So we can consider water here as a Bronsted-Lowry base. Next one is acid and base according to Gilbert and Lewis. So according to him, acid is a substance that accepts electrons, while base is a substance that donates electrons. So an example here will be calcium oxide plus carbon dioxide. This is supposed to be capital. So these two reacts to create calcium ion plus carbonate ion, which if you want to further complete the reaction, it will become calcium carbonate. But here we pay attention in these two parts. So calcium oxide turns into calcium and its charge become positive 2, or we can say that it lose two electrons, or we can say it donates the electron. So calcium oxide here is a Lewis base, while carbon dioxide, initially CO2 has a charge of 0, and then it becomes CO3 with a charge of negative 2, which means it gains electron, or it accepts the electron that has been donated by calcium oxide. So we can say calcium oxide as Lewis base, while carbon dioxide is a Lewis acid. So next, how do we identify acids and base if we don't know, for example, their chemical name? Then this is done by an indicator, which I will explain a bit later. First is pH, or power of hydrogen. So power of hydrogen, or pH, let's just say pH lah. pH is the measurement for how acidic or how basic a substance is. So, and it range between 1 to 12, with 7 being the neutral. So you can imagine here as this one 7, this is 1, and this is 14. And the lower it is, the more acidic it is. Getting lower will become more acidic, while the higher it is will become more basic. Right. And we can identify in real life what are acids and what are base, or more specifically identify with the pH level is by an indicator. So an indicator is a substance that change colors when they are added to acidic or alkaline solution, which behind here we already have one example, which is the litmus paper. When it is in contact with acid, it will turn into the color red, while if it is in contact with base, it will turn into the color blue. Right. And here are some more examples of indicators. We have bromophenol blue, which turns yellow in acid and it turns blue in base. And then bromothymol blue turns yellow in acid and turns blue in base also. Chlorophenol blue, same with the earlier two. Then cresol red color change into yellow in acid, and when in base it is the color red. Then we have methyl orange, which turns into orange when in acid and turns into yellow when in base. Then methyl red, which turns into red in acid and yellow into base. Phenolphthalein, which is colorless in base. Which is colorless in acid, sorry. And it is reddish pink in base. And lastly, we have thymol blue, which is color red in acid and also yellow in base. And next, finally, we have chemical reactions that involve acids and base. So for this one, I will divide them into three, which is the reaction that involves only acids, and then reaction that involve both acid and base, and then lastly, reaction that's only involved with base. So in reactions involving acids, we have 1, 2, 3, 4, 5 here. First one is reaction of acid with a reactive metal, reaction of acid with carbonates, reaction of acid with bicarbonates, reaction of acid with metallic oxide, reaction of acid with metallic hydroxide. So let's start with the first one, which is reaction of acid with a reactive metal. So in this reaction, we have a metal which reacts with the acid to create salt and hydrogen gas. Here I have some examples. First is magnesium added with sulfuric acid. So here magnesium is the metal, while sulfuric acid is the acid. It turns into magnesium sulfate and also hydrogen gas. So the magnesium sulfate here is the salt, and also of course hydrogen gas, self-explanatory. Next we have aluminum as the metal and also hydrochloric acid as the acid. And these two reacts to create aluminum chloride as a salt and hydrogen gas. And then another one is called copper, which reacts with ammonia. Here, copper is the metal and the acid is ammonia, which reacts with, it's supposed to be a salt. But why is it here no reaction? Well, because if you pay attention to the name, this is the reaction of acid with a reactive metal. So it can only react with a reactive metal, which copper is not. And copper is not. And this is determined by this table of activity series of metals and halogens. Let's pay attention to only the metals here. From this here and all the way to here, these are the metals that can react with an acid. So if you look closely, there's magnesium is there, aluminum is there, but copper is not. Copper is actually all the way here, which does not react with acid. This here, when reacting with acid, will produce an NR, or we call as no reaction. So we have to pay attention to this. Always pay attention to the table of activity series. And moving on to the next one is reaction of acid with carbonate. By reacting carbonate with acid, we get salt, water, and carbon dioxide. Here, I have an example. Calcium carbonate is the carbonate, and ammonia is the acid. It will react to create calcium chloride, which is the salt, water, and also carbon dioxide. And next is the reaction of acid with bicarbonate. So reacting bicarbonate with acid will provide the same result with reacting with carbonate, which is salt, water, and also carbon dioxide. So here I have sodium bicarbonate as the bicarbonate, and then hydrochloric acid as the acid will create sodium chloride. You guys should be familiar with this. Sodium chloride is table salt, and then next is H2O, which is water, and carbon dioxide. Next, we have reaction of acid with a metallic oxide. So by reacting metallic oxide with acid, we get salt and water. So here we have zinc oxide as the metallic oxide, and then we have sulfuric acid as the acid, which will react to create zinc sulfate, which is the salt, and also H2O, which is water. Next is a reaction of acid with metallic hydroxide. So the last one that only involves acid, reaction of acid with metallic oxide, we get metallic oxide and acid will create salt and water. So these two will get the same result. Here we have zinc hydroxide, which is the metallic hydroxide. Then we have acid, which here is the nitric acid. We will get the salt is zinc nitrate, and then here we have water, right? So next we have the reaction that involve both acid and base. So there's only one that we're going to learn here, which is the neutralization reaction. So when you react with acid and base, it will create salt and water. So here we have hydrochloric acid, which is the acid, self-explanatory, we know from the name. And then here is sodium hydroxide, which is the base. It will create table salt, sodium chloride, and also water. Another example would be hydrochloric acid, and the base is barium hydroxide, which will result in barium chloride, which is the salt, and also water. Right. And finally, we have chemical reactions that involve only base. So for chemical reactions that only involve base, there's two. First is reaction of base with ammonium salt. So reaction of ammonium salt with base will result in salt, water, and ammonia gas. Here the ammonium salt in this example is calcium wait, no, calcium hydroxide is the base. And then here we have ammonium chloride, which is the ammonium salt, which results in calcium chloride, which is the salt, and then water and ammonia gas. And the last one is reaction of base with a metal salt. So salt 1, which is, let's just consider this as the first salt, plus a base will result in salt 2, or a different type of salt, plus metallic hydroxide. So here ferrous sulfate here is the salt, and base is the sodium hydroxide, which will result in a new salt, sodium sulfate, and also a metallic hydroxide, which is here ferrous hydroxide. So that's the last one for the chemical reaction that involve base. And that's all. The video, the lesson for this time is only until there. So thank you for watching until the end. I hope that you find this educational and enjoyable. Don't forget to leave a like or maybe subscribe if you want to. And have a nice day.